Hello friends, welcome to this video, and this video is a part of YouTube series Data Science and Machine Learning. Those who want to become a data scientist or those who are already an expert in data science and want to extend their knowledge, this YouTube series is for them. So let's see. Uh, in a last video we have seen that how we get a samples, then samples can be projected on the different dimensions to get a feature vector. Okay, and those feature vectors will be representing that sample. There will be so many samples which can be plotted on a one dimensional. If the problem is of the one dimension, we can put them, we can plot them on the one line. If the problem or the samples are represented by the two dimension, then we can have a 2D plane kind of thing. If it is a three dimensions, we can plot them or visualize them in a 3D space. And you can see there is a 2D plane is used to classify or separate the two classes of these cartoon faces. Okay, so now if we have to think about the four dimensions or the multiple higher dimensions, then there is no way that we can see that. But we have come to the one conclusion in a last 11th video, that we get a boundary, we get a decision boundary. If the problem is a one dimensional, then one constant is enough for classifying or for separating the two classes. If it is a two-dimensional data, then the line is a decision boundary or decision line is enough to separate out the two types of data points. If it is a 3D space, then the 2D plane will be required. But if it is a four-dimensional data or higher dimensional data, then we call this decision boundary as a hyperplane. Okay, so let's see the property that is a linear separability. Okay, so in a linear separability, if you see, if we take an example of the AND gate, AND gate is nothing but the y is equal to x1 into x2. If it has a two inputs x1 and x2, then y is nothing but the product of those two inputs. So we can plot the AND gate in this is called the truth table. So x1, x2, and what are the digital combinations are 0 0 0 1 1 0 and 1 1. And then with respect to this x1 and x2, what is going to be y? So 0 and 0 are inputs, and the output is going to be 0. 0 and 1, output is going to be 0. 1 and 0, output is going to be 0. And 1 and 1, then output is going to be a 1. Now, just to differentiate from the inputs values and the output values, because inputs are also 0 and 1, outputs are also 0 and 1. So just to differentiate the output from the input values, we will use a symbols, a circle for the 0 and triangle for the 1. Now let's plot this x1 x2 with and their output. So this is the x1 axis, this is the 0th point, this is the 0 value, and this is the 1 value on the x1 axis. This is 0 value on the x2 axis, this is the 1 value on the x2 axis. Now if 0 and 0 both are 0 and this, so here, and what is output? Circle. So we plotted a circle here. Okay, if it is a 0 and 1, so 0 on x1 axis and 1 is on the x2 axis, and then this is the position, and in position again it's a output is a circle, so or the 0, that's why we have put a circle here. Okay, now 1 and 0, so 1 on the x1 axis and 0 on the x2 axis, so this is the position, and in this position the output is a circle, so we have plotted again the circle. Now last one, the 1 and 1, so 1 is on the x1 axis and x2 axis also 1, so they will intersect here at this point, and then what is the output out here is a triangle, so we drawn a triangle, we plotted a triangle out here. Now let me just draw one random line and try to separate the circles from the triangle. Separating the circles from the triangles or triangles from the circles is nothing but finding the line of which one side will have a one type of class and another side will have a another classes. So in this case, if we plot this line, suppose, though it is randomly, this is not separating the classes because the one side has got a triangle as well as a circle, and here the two circles this side, so they are not completely separated. Let us see the next line. Even this line is not, because the one side of this line, this means this side of the line has got a circle and triangle, and this is circle circle. Okay, so not completely separated the classes. What about this line? If I plot this line, again it's not, because the two circles and triangle are on the one side, so not a separable. Let's see this line. I think this solves the purpose, because the one side of this line has got only one triangle and all the three circles are on the another side of this line, and that's why this line is separating the two classes completely, and that's why this is the separating line. Okay, and I think this is separating the classes. This is kind of the hyperline, and we can, you know, we can say that this AND problem, okay, this AND system is a separable. It has a linear separability property. Okay, their classes has got a linearly separable. Let's move on to, okay, so this is the green line, just it is able to separate out, but this line is not able to. Okay, so but this is line, so that means this classes has at least the one line. This output classes has at least a one line which can separate out these two classes completely. Okay, so that green one at the line is. Now another problem is just the notations for the people who did not have the digital electronics. So it is like a bar you write, or in a programming language then exclamatory A, that means not A, or even we write the not A. Even I think most of the digital electronics books, they will write A bar, that means A, and top of A there will be the one line. So that's nothing but the complement of the A. If the A value is a 1, then A bar will be 0. If A value is 0, then A bar will be 1. Okay, so it just complement the what is the value of A. So now XOR is given by y is equal to x1 into x2 bar plus x1 bar into x2. Okay, this quote is nothing but the, I'm calling it bar. So y is equal to x1 into x2 bar plus x1 bar into x2. Okay, so let us repeat the AND gate procedure here. Only while calculating the output we will consider this equation and not this one. So x1 0 0, so 0, okay, into 1 it will be, okay, because x2 is 0, so x2 bar will be 1. So 0 into 1 0 plus x1 bar x2. So what is the x1 bar? It's a 0, that means 1, and x2 is also 0, so it is already 0, so 1 into 0 is going to be 0, so 0 plus 0 will be 0, so output is 0. Okay, now next combination 0 and 1, so this is going to be a 0 and 1 bar, that means 0 plus, so 0 into 0 is equal to 0 plus this side, let's see, x1 bar, that means 0 bar is 1 into x2 is already 1, so 1 into 1 1, so 1 plus 0 will be 1. Okay, and similarly if you go for the 1 comma 0, that means this is the 1 and x2 is 0, so 0 bar will be 1, 1 into 1 1 plus x1 bar is x1 is 1, x1 is 1, so 1 bar will be 0 and x2 is already 0, so 0 into 0 0, so 1 plus 0 is equal to 1, and that's why output is 1. Now if we put a 1 and 1, that means 1 into 0 plus 0 into 1, so this side also 0, this side also 0, 0 plus 0 is equal to 0. And then output symbols we have used a circle for the 0 and one triangle for the 1, and we plotted this. Okay, so let us be very careful while considering these outputs. 0 and 0, that means what is the position, this, and what is the output, circle we have drawn. Okay, 0 and 1, so 0 and 1. Okay, so this is the position, and what is the output is a triangle. Okay, 1 and 0, so 1 on x1 and 0, so this one. Okay, so here this position we will get. Now this is again the triangle. 1, next combination is 1 and 1, so 1 and 1, so here it will intersect, and this is going to be position 1 comma 1, and what is the output is a 0. Now this is a 0. Okay, circle, right? Okay, so now let us try to draw a line, try to find out the line which can separate out the triangles from the circles or circles from the triangle. So this, I have taken a line, and is it separating? No, because one triangle is here, one triangle is this side, circle is this side, and circle is this side, so that's not. Let's see, not the two line, but then consider one line at a time. So if this is the line, no, this is also not. Even this is the line, no, even this is the line is not. One triangle is here, but another side of that line has a circle, triangle, and circle, so both the classes elements are there, so that's not separating. Okay, so because this is not separating, that means this is not a linear separable problem. That means because you won't have any line which will able to separate out the triangles from the circles or circles from the triangles on this plane, and that's why this XOR problem is not a linearly separable. Okay, that's a conclusion of these slides. Let's move on to the next. Let's try to overcome that issue if we can. So we have a same thing, the x1 x2 y output 0 0 0 1 1 0 1 1, and then y is going to be 0 and 0, the y is going to be 0, then 1 1 1 0, because XOR is nothing but the whenever the two inputs are the different, then output will be 1. If the two inputs are same, then output is 0 actually. So output is going to be same. We have seen this on the last slide. And now if we plot this, we are going to get like this: triangle triangle, circle circle. Okay, and there is no line, there is no line which will able to separate out the circles from the triangle or triangle from the circle, and that's a issue of the XOR, which is also called as a XOR is not linearly separable. Now we can make that problem a linearly separable by using a feature engineering. If we could do some the processing on the inputs, then can we make a 2D space points as a linear separable of the XOR. So what we will do, let's focus on this table first. We have a x1 x2, they will be as it is, all the combinations, but but before reaching to the y, before deciding the y, we will not decide y on the basis of these x1 and x2, but we will have a two intermediate inputs which will be the function of x1 and x2. Okay, so this is the one input, this is the column is a one input which is going to be a function of x1 and x2, and what is that? Not x1 or bar x1 into x2. Okay, and the another input is of again function of the x1 x2, it is x1 into x2 bar or not x2. Okay, so let's calculate all these value for all this combination of x1 x2. So what it is going to be? 0 and 0. So if we put a 0 as a x1, it is going to be 1. x2 is already 0, so it's going to be 0. 1 into 0, 0. This is x1 is 0 and not x2 is going to be 1, so 0 into 1, 0. Okay, now next combination, so 0 not, okay, so that means 1, and x2 is already 1, so 1 into 1, it is going to be 1. Okay, x1 bar, okay, so this first combinations we have calculated. Second one is a 0 into 1, so 0 into 1, 1 into 1, x2 is already 1, so it's going to be 1 into 1 is 1, and this is going to be 0 is 0, and then anything multiplied by 0 is going to be 0 only. Now next combination 1 and 0, so 1 will, this will become 0, anything multiplied by 0 will be 0, so this is going to be 0 only. And next is a 1, x1 is already 1 and x2 is 0, so bar x2 will be 1, so 1 into 1 will be 1. Similarly you can calculate for 1 and 1, and this will be 0 and 0, so output is going to be 0 1 1 0. Now we can, you know, we can add a 0 and 0 0. If 1 and 0, it's a different one, okay, they are the different one, so 1 0 1, and so now on that we are on these intermediate inputs we are using a XOR system, okay, and not directly on that. So now y is equal to, we got a 0 1 1 and 0, and input is like this, okay, 0 0 1 0 0 1 and 0 0, and outputs will remain same, right, because anyway our application will have a inputs this, so input to output mapping will be same. But now we have got these inputs intermediate, so these are plotted on this line, and let's see if it is a separable or not. So 0 and 0, so we have got a 0, okay, so you can see this is the AND x1 x2 bar. So okay, the first one is a x1 bar x2, and means product, so product of x1 bar and x2, so x1 bar means not x1 into x2, okay, this is x1 into x2 bar, so here also x1 into x2 bar or not, right. So this corresponds to this axis and this corresponds to this axis. Okay, so if we plot a 0 and 0, 0 is coming here, 0 is coming here, and this is the 1 0, okay, so 1, its output is circle, one circle, okay, second circle we will see 1 comma 0, so 1 comma 0, so this position, and this is triangle. Now 0 and 1, so 0 and 1, so this is also triangle, 0 and 1 triangle, okay. Now 0 and 0 again, so 0 and 0 again, so it's going to be circle, so another circle. Now you can see this is the line which is able to separate out the triangles from the circles, and that's why it has become now a linearly separable problem. So the problem which was not linearly separable can be made a linearly separable by using a feature engineering, right. So what is next? Okay, so I think we have seen there are columns or the dimensions or the features. So can there be more number of columns? We have already seen the 2 dimensions. We have also shown on the graph the 3 dimensions, There are some real life problems, or there are so many real life problems where the dimensions will be very very high. It could be 10, it could be 15, it could be 100, it could be 1000, it could be 10,000, it could be 20,000, it could be millions also. Okay, believe me, we have that kind of a problems in a real life. Okay, so there is no limitation on that. Can there be different solution or classification methodologies other than two we discussed so far? Yeah, so classification we have seen like a KNN, then we have seen I mean we have seen the theoretical, the data can be plotted, and then we can find out the separable line. Okay, so yes, I think there are the methods, and as we go on in this course, I think we will see more and more methods, and not just that, but there will be again the classes of the methodologies, and they will have a parameters and all, and we will have so many variants of machine learning algorithms. So third is, what could be a way to describe or represent the samples? I think we have seen in the last video, if there is a sample, we are projecting it on the different you know, different features, different dimensions, and its value forms from a feature vector, and that is used to represent the sample. So yes, I mean there are so many ways, and there will be the philosophy behind representing the sample. Some representation will be simple, some representation will be obvious, and some could be even the complex to represent. Okay, so next question, the what could be optimal representation under classifier? Yes, optimal representations, I think whichever gives a better results, whichever gives a good classification results, or whichever representation gives the results as per our objective, that's the optimal representations. So it's a like a, you know, we need to use a trial and error, we need to use a combination of the theory and trial and error, and see, and then which kind of the data we have, and then see the results, and then I think we will be in a position to take a decision whether it is optimal representation or not. What are the other types of similarity measurement? Yes, we have used a simple sum of absolute difference, that is SAD, in a KNN classifier. There is also one Euclidean distance, or the mean square error. And of course there are 10 more or 15 more different similarity measurements. We will have I think one video on especially on the similarity measurement, or the calculating the differences or dissimilarity. Is there always a need to store the training data set so that it can be used in applying the classification during the testing? Yes, I mean that's a very good question. I mean, it's a, you know, in a KNN classifier we are storing the data as it is, and whenever the test sample comes, we have to compare with all those training samples. That means at the time of the testing, whenever the training got over, if the training gets over, even at the time of testing or using that trained KNN classifier, we need to have that data as it is in our memory. But that is not the case in so many other machine learning algorithms, and those data maybe, you know, sorry, maybe millions of the data, or very 10 millions of data. If it is a less, it's good. So those storage may not be required, because at that, but during the training we will need that data, and we will make some classifier function, and we will represent the whole data or the trained object as a some kind of the coefficients and all, and I think those coefficients will not take a memory as much as all the training samples will take. And that is why during testing, you know, there are so many algorithms where during testing we will not need all the data we use for the training, or not at all any data used for the training, but the whatever is derived from that data, and that will be a smaller version in a data point of view or the memory point of view, and that is going to be used while using that trained classifier or while testing. Okay, so there would be so many questions in the mind of ML learners or developers, and this course will find the answers of all these and other questions. Okay, so that's it for this video.